Concept we're reviewing in this video is the equation of a line y equals mx plus b, which we call the slope-intercept form of a line. And if you have the equation of your line with y isolated, then the coefficient of x will be the slope and the constant on the end will be the y-intercept. So if I ask you to sketch this equation, the nice thing about this is that y is isolated. So the equation is of the form mx plus b. The slope, which is the letter m, is negative 4 over 3. And the y-intercept, which is the letter b, is 2. And if I have 2 points, I can graph a line quickly. If I have 1 point and its slope, I can graph a line quickly. So that's exactly what I have. I have a point. The graph crosses the y-axis at 2, and from there, if I do a slope of 4/3, negative, if I drop 4 from here and run 3, I'd land there. Of course, the negative could have been on the bottom, so I could have gone up 4 and left 3. But again, we know that a line has a constant rate of change. It has a constant slope. And so, using a ruler, which I can't do here, but you can, I show all the points with that condition. Any 2 points on that segment has a slope of negative 4/3. Connect them with an arrow at the end. Alright, let's do the reverse question. This time we're given the graph and we want to come up with the equation. So we know how to work with y equals mx plus b. M is the slope, y-intercept is b. So if I look at my graph, if I can identify these two values, I will have the equation of the line. Well, my y-intercept, the graph crosses the y-axis at negative 2. My slope, my m, my rise over run, if I start at one point and move in a continuous pattern to the other, so I know these 2 points, I can see them specifically on the graph. If I rise 2, up 2, run 3, right 3, that's a slope of 2/3. So I then take these 2 pieces of information, I substitute them into the equation of a line. The equation of the line is y equals 2/3 x minus 2. Alright, our last question. Find the equation of a line with a slope of 2/5 passing through the point negative 3, negative 1. Alright, I'm just going to draw a little sketch of this just to better understand what's happening. So we have a line and it's passing through this point. Okay. And from there I have a slope of 2/5, which means I need the markings to go up 2 from there. 1, 2, 1, 2, 3, 4, 5, there. So I want the line that looks something like that, the equation of that line. Well, I can build the equation of a line with y equals mx plus b. That I know I can do. And I do know the slope, so I can put the slope in for m. So y equals 2/5 x plus b. Now to get the equation of the line, I need the value of b. My x and y represent any point on the line. My y-intercept, I don't know it specifically as I did in the last example. I can see that it's somewhere between 0 and 1, but I can't see exactly what it is. So what I can do here is, because I know that the line passes through this point, I know that this point must satisfy the equation for x and y. So I'm going to substitute these values of x and y into the equation. So negative 1 equals 2/5 times negative 3 for x plus b. Okay, now just keep in mind here that x and y are a lot of different values. Okay, this is just one set of values that will work in this equation. Any point on this line is a value that needs to work for x and y. But there's only one y-intercept. So what we're doing is we're using one specific point for x and y to calculate the only value that's possible for b. So we have a little bit of number crunching to do here. So we have negative 1 equals negative 6/5 plus b. If I add 6/5 to both sides, this would be negative 5 over 5 plus 6 over 5, which is 1/5. My y-intercept would be 1/5. I can then put that back into the equation of a line, and so my final equation of a line is y equals a slope of 2/5 x, mx, plus b, the y-intercept, 1/5. And my y-intercept is between 0 and 1, as it looks is the case on the graph, and therefore things look like they should be correct.